Are black holes really these, bottomless pits in space?
Yeah.
Just cosmic vacuum cleaners sucking everything in?
Or maybe could they be something, well, something much stranger right at the edge?
Exactly. Let's dive into that because we came across this theory that really makes you think it might just flip everything we thought we knew about them.
Yeah, it's a totally fresh look at black holes. It really challenges the whole idea of what's inside.
Right. Physicist Neil Turok proposed it. We saw it discussed in this great video on the Kurt Gongol channel called The Most Astonishing Theory of Black Holes Ever Proposed.
Hmm.
Anyway, I'm Nick,
And I'm Pi.
and this is The Deep Dive. Our job really is to take these big, complex ideas, pull them apart, look at them from different angles, and this time there's something extra special in the mix for you, our listener.
And that's the really striking part, isn't it? How Turok's ideas, his theoretical framework, seem to line up in surprising ways with the temporal experiments your father worked on.
It is. That connection just jumped out at us. Obviously, the details of your father's work, that's all yours. But the concepts, the way they echo Turok's theory, it's hard to ignore.
So Doc's not thinking cosmic drain. He's thinking,
Black mirrors, that's the term he uses. Forget the singularity, that point of infinite density inside.
yeah.
Instead, picture a surface, a boundary, and something really, really weird happens there.
Okay, so what's happening at this boundary then? What's the weird part?
Well, according to Turok, it's where matter meets its antimatter twin, maybe from like a mirror universe.
Okay.
And instead of falling in, they just annihilate right there at the horizon.
Poof.
Yeah, basically.
Yeah.
So our mission for this deep dive is to unpack this black mirror idea, see what Turok's getting at, and really importantly for you, explore where it seems to click with what your father was investigating about time. It's going to be a wild ride right to the edge.
It's such a huge shift from the usual picture, isn't it?
Yeah.
The standard black hole, you hit the event horizon, you spiral down to a singularity. End of story. But Turok and his team, they're saying the horizon is more like a gateway, not into the black hole, but to a sort of reflection of our universe, a CPT inverted reflection.
Okay, CPT, let's break that down quickly. That's charge conjugation, parity inversion, and time reversal, right?
Exactly. It's a fundamental symmetry in physics. Basically, if you flip a particle's charge, mirror its spatial coordinates, and run time backwards for it, the laws of physics should still work the same.
That's the principle.
Right. And this black mirror idea suggests that when you get near a black hole horizon, you're not going inside. You're hitting a boundary with a realm that's undergone that CPT flip.
So, like a universe where everything's got the opposite charge.
And it's spatially mirrored?
And time flows backwards. Whoa.
That's the concept. The black mirror is the border to that CPT symmetric reality.
So the horizon is kind of a window, or a mirror, I guess, into an anti-reality, a time-reverse version of us.
That's one way to think about it, yeah. The actual physics paper shows how this black mirror solution mathematically connects the outside space-time we know, around the collapsed star or whatever, to its own CPT mirrored version.
And the key thing is?
The key thing is this connection, this mathematical bridge, manages to avoid those singularities, those points of infinite density that just break physics in the standard model.
Yeah. The singularity always felt like a point where the maths just gives up, doesn't it?
Yeah.
Like, we don't know what happens here.
Absolutely. It's a breakdown. The black mirror offers a different interpretation of Einstein's equations in that extreme gravity scenario. And like the video discussion pointed out, it neatly sidesteps that whole singularity problem.
Okay, and this is where it gets really interesting, connecting back to your father's work. This whole concept of a mirror reality, especially with time reversal baked right into the CPT symmetry. It really seems to touch on themes that might have come up in his temporal experiments. We don't know the specifics, of course, but conceptually, it's very close, isn't it? Could he have been sensing something about reverse time? Or interactions with some kind of CPT-flipped domain?
Well, if you look at CPT symmetry, time reversal is right there in the T. It's fundamental.
Right.
And there's this famous interpretation, the Stuckelberg-Feynman idea, that basically views an antiparticle as just a regular particle moving backward in time.
Okay, yeah, I've heard that.
So there's this deep link between particles, antiparticles, and the flow of time. It could offer a completely new way to think about any weird temporal effects your father might have been observing.
It's like these two fields, super theoretical astrophysics and your father's hands-on temporal research might actually be pointing towards the same deeper thing about reality.
It's possible.
The video transcript even mentioned Turok talking about the sort of two-sided nature you often find in these solutions in general relativity. He compared it to their cosmological model, where maybe the Big Bang itself had a kind of mirror image starting point with time going the other way.
That two-sidedness is definitely a recurring theme in GR solutions, whether for black holes or the whole universe.
Uh-huh.
And the black mirror idea really leans into that. It says the horizon is like the seam, the place where these two sides, our universe and its CPT mirror, are joined. But crucially, there's no inside to the black hole itself.
Right. I remember Turok saying something like, you hit the horizon on one side, and you come out on the horizon on the other side into the other universe. There is no black hole interior.
Yeah.
That's a huge shift.
It really is. And think about the implications for things like the information paradox.
Okay, yeah. What happens to stuff that falls in? Where does the information go?
Well, if there's no inside for it to fall into and get lost, maybe the paradox just dissolves. The information in this picture never actually crosses into an interior because, well, there isn't one.
Okay, that's elegant. And what about the firewall paradox? That idea of a super high energy wall at the horizon.
Yeah, the firewall comes from trying to make quantum entanglement work nicely with general relativity near the horizon. It gets messy.
Right.
But the black mirror model, again, by getting rid of the interior, might just sidestep the conditions that lead to a firewall. The paper hints that the matter-antimatter annihilation at the horizon,
The poof.
right, the poof, that it turns everything into radiation, that process could be how information gets re-encoded and radiated back out so it avoids the whole firewall issue.
So the mirror isn't just passive, it's active.
Yeah.
It's where matter meets antimatter, and they basically turn into energy.
Exactly, a very dynamic boundary. And that fits perfectly with the CPT symmetry that's driving the whole theory. Turok explained in the video how a particle falling in would meet its antiparticle partner coming from the anti-universe right at the horizon.
And they annihilate.
They annihilate, releasing radiation.
So it feels like a more complete story, maybe? Like Turok described it. You get the black hole forming, then it eventually evaporates through this annihilation radiation, kind of like Hawking radiation, but from a different mechanism. And the matter that made it isn't lost inside, it's transformed at the boundary.
And the math seems to back this up in interesting ways, too. The paper talks about the space-time metric, the thing that describes gravity and geometry. They say that even though you can make the metric look smooth across the horizon with the right math tricks, two of its basic properties, called eigenvalues, they sort of swap roles and hit zero right at the horizon.
Eigenvalue swapping. Okay, that sounds technical. What does that mean, sort of practically?
Think of them as describing key features of gravity's pull in different directions. The fact they swap and go to zero suggests there's a real, though maybe mild, change in space-time's fundamental nature right at that boundary. It's not just an illusion caused by our coordinates, like some other horizon features can be.
And the video discussion also flagged that eigenvalue switch, didn't it? As something really marking this black mirror horizon as different from a standard event horizon.
Right. And the paper shows this whole black mirror solution pops out quite naturally if you start your quantum calculations using something called the path integral by insisting on CPT symmetry right at the boundary.
So you put CPT symmetry in as a rule at the edge.
And the black mirror is what the maths gives you back. It's not just a weird idea, but maybe something fundamental coming from quantum gravity principles.
So starting with that deep symmetry leads you to this totally different idea of what a black hole is.
Exactly. And it might also help with another old puzzle, how black holes fit into thermodynamics, into heat and equilibrium.
Ah, okay.
The standard picture struggles a bit with CPT because it doesn't naturally include white holes, the time-reverse version of black holes. But the black mirror, because it's inherently CPT symmetric and linked to its mirror universe, suggests a more balanced picture where black holes and their time-reverse twins are kind of built in together.
This constant annihilation, matter meeting antimatter, feels like that should produce something we could maybe see. Some kind of signal.
That's the tantalizing bit, isn't it? The video transcript mentions it, the possibility of observable signals from that annihilation at the horizon.
What?
But as Turok himself says, figuring out exactly what those signals would look like, how strong they'd be, that's really complex. It's still very much ongoing research.
So it's a theory that's still being worked out.
Yeah.
Makes sense.
Yeah.
But the potential is huge, especially when we think again about your father's work.
Yeah.
The whole idea of boundaries between different time directions, or just the fundamental nature of time near these intense gravity points.
Yeah.
It feels like Turok's framework could offer a really surprising new lens for that.
Remember the old Einstein-Rosen bridge idea? Wormholes. connecting two places through the inside of a black hole. The black mirror is kind of similar in being two-sided, but there's no inside tunnel. It's like the two outside regions, our universe and the mirror one, are directly stitched together right at the horizon itself, with CPT being the transformation that happens at the seam.
Okay, let me try and sum this up for you and for us.
Yeah.
Turok's saying, black holes, not voids. They're dynamic surfaces like mirrors.
Right.
They're linked to a mirror universe by this fundamental CPT symmetry. Matter and antimatter meet at the horizon and annihilate constantly.
Yep.
And this whole picture might solve major problems like the information paradox and the firewall paradox. The horizon itself isn't just a point of no return. It's a unique boundary where spacetime fundamentally changes, shown by that eigenvalue swapping.
Nicely put. And connecting it back one last time to your father's experiments. The way this theory talks about time reversal, mirror realities, the nature of reality right at these extreme edges, it just resonates, doesn't it? Even without knowing the exact findings of his temporal work, the conceptual parallels with Turok's physics are, well, they're really quite striking.
It really leaves you with a big question, doesn't it? Could these things we call black holes, these supposed destroyers, actually be cosmic mirrors? Not reflecting light, but reflecting reality itself. Maybe even giving a peek into another universe where time runs backward, a place your father's work might have somehow touched.
Or maybe think about it this way. If that horizon really is this active place where matter from here meets antimatter from there, annihilating across time's boundary, what does that truly tell us about time itself, its fundamental nature? That's the kind of deep question your father spent his life exploring.
Definitely check out Neil Turok's work if this sparked your interest. The Perimeter Institute is a good place to start. Look for his papers. And maybe looking at your father's notes again through this black mirror lens. Perhaps even more connections will jump out. Thanks for exploring this with us on The Deep Dive.